Good morning, students. So in the previous lecture, we were discussing about slope deflection method, and we tried to solve one question, so which was left incomplete. So in this lecture, we will try to complete that question. So for a quick revision, I'm drawing that question again here. So this was our beam. This is A, B, C, and D. 4 meter, 4 meter, 4 meter, and this support C sinks by 10 millimeter. Okay, and E was given as 2 into 10 to the power 5 Newton per square. I is given as 3.6 into 10 to the power 7 millimeter to the power 4. So there are no loads on this beam. Okay, only the support C. The support C is sinking by 10 mm. Okay, and due to this sinking of support C, some stresses and strains are coming in our continuous beam, which we need to analyze. Okay, which we need to analyze, and we need to draw SFD and BMD. So first we will calculate kinematic indeterminacy dk, which will be equal to 2, 1 here, theta b and theta c. So these two will be our kinematic indeterminacy. The first thing is to calculate the dk. Then our step 1 will be finding fixed end moment. Okay, for example, for span AB, this is our span AB. This is A, this is B. Okay, for this span MF AB will be equal to 0, and MF BA will also be equal to 0. Why these are 0? Because there is no load on this span. Okay, I have already given you a table for all the fixed end moments. I have sent you the images via WhatsApp, so you can refer that image. So this is for span AB. Next, this is for span AB. Similarly, for span BC. So here it is our span BC. This is our B and this is C. Okay. So one thing we need to remember is, whenever we will calculate fixed end moments, we will always consider both ends of the beam as fixed beams. So the end B is fixed and C is fixed, and it is given that our support C is sinking by 10 mm. So this support will sink by 10 mm. So now the new condition will be like this. Okay, so due to this sinking of support, what happens? Two moments will develop like this, which will try to make this slope at both the ends as 0, and the magnitude of these two moments will be 6 ei delta upon L square. Similarly here also 6 ei delta upon L square, where L is the length of span and this delta is the sinking magnitude of sinking. E and I are these values: modulus, Young's modulus, and moment of inertia. So MFBC will be 6 EI delta upon L square. Since it is anti-clockwise, and we know that for all the anti-clockwise moments will be taken as negative. Okay, so it will be minus 6 into E is 2 into 10 to the power 5 Newton per mm square, and I is 3.6 into 10 to the power 7 millimeter to the power 4, and delta is 10 mm upon this L square 4 into 10 to the power 3 whole square. So we will solve it. Okay, so it will come as minus 40.5 kilonewton meter. So you can solve it on your own. Okay, similarly when we will calculate MFCB, then it will be plus 6 EI delta upon L square. 6 E is 2 into 10 to the power 5, I is 3.6 into 10 to the power 7, delta is 10 millimeter, and this will be 4 into 10 to the power 3 whole square. Okay, this will come in Newton millimeter. Then we will multiply it with 10 to the power minus 6, and we will get 40.5 kilonewton meter. Okay, so similarly for span CD, this is our span C and D, C and D. Okay, so now the support C is sinking by 10 mm, so this will sink by 10 millimeter. So the now new support is here, so it will be like this, and the reactions will be, the movements will be this and this. Okay, the movements will try to, they will try to make it straight here. They will try to make the slope 0 at the ends. Why they are doing this? Because it is a fixed beam, and for a fixed beam the slope should be 0 at the ends. So now this is 6 EI delta upon L square, and this is 6 EI delta upon L square. So MFCD will be equal to 6, since it is clockwise, so we'll take 6 EI delta upon L square as positive. This will be positive. So 6, 2 into 10 to the power 5, into 10 to the power 5 into 3.6 into 10 to the power 7 into 10 mm upon 4 to 10 to the power 3 whole square. Actually, we are doing one mistake here, and that mistake is in the previous this question, these values are given as 2i, 1.5i, and 2i. Okay, so these are given. So here also, in place of this I will write, it should not be I, it should be 1.5i. Okay, so here I will multiply with 1.5, then I will get minus 40.5. Similarly here also MFCB, here also this I will be 1.5 into I. So here I will multiply here by 1.5. So I'm writing it like this, 1.5 into 1.5. Then you will get this. Similarly here also I will write 2i in place of I. So here I will multiply with 2. Okay. Similarly here also I should write minus 6e into 2i delta upon L square. Okay. So minus 6 into e is 2 into 10 to the power 5. 2 into I is 3.6 into 10 to the power 7 into delta is 10 millimeter upon 4 into 10 to the power 3 whole square. This will come in Newton per millimeter square. Then I will Newton millimeter. Then I will multiply it with 10 to the power minus 6, and the answer will come in 54 kilonewton meter. Okay, this is our MFDC. So this is our first step. Okay, we will calculate all the fixed end moments. Now in the second step, what we will do, we will write slope deflection equations. Second step, slope deflection equations. So we will write slope deflection equations. Now for all the beams, for all the spans, I mean AB, here for AB, BC and CD, for all the three spans we will write two equations for each. So there will be a total 6 number of equations. So first we will write for AB. So MAB will be equal to MFAB plus 2EI upon L brackets 2 theta A plus theta B minus 3 delta upon L. Okay, so MAB will be equal to MFAB. What is the value of MFAB? We have already calculated it. MFAB, this one. So MFAB is equal to 0. So we'll put it as 0 plus 2EI upon L is 4. And this I is 2I. We are writing for AB. So I will be equal to 2I. Okay. Into brackets 2 into theta A. What will be the value of theta A? Since the support A is a fixed support, so value of theta it will be equal to 0 here. So I will put theta A equal to 0 plus theta B minus this delta will also be equal to 0. Why this delta is 0? Because this support A is not sinking at all. So the equation will be MAB equals to 414 EI brackets into theta B. This is our equation number 1. Similarly, for MBA, we will write MFBA plus 2EI upon L and here I will be 2i, and brackets में 2 theta b plus theta a minus 3 delta upon L. Okay, so here MFBA is 0, theta a is 0, delta is 0, so MBA will be equal to, and this L is 4 meter. Okay, so MBA will be equal to 2EI theta b. This is our question number 2. Okay, this is for span AB. Now similarly we will write for span BC, and what will be that? MBC will be equals to MFBC plus 2EI upon L, I guess 2 theta B plus theta C minus 3 delta upon L. Okay, and here I will be equals to 1.5 I, and L is 4 meters. Okay, now span BC, I'm talking about this span. Okay, span BC, what is happening in this span? The support C is sinking by 10 mm downward. Okay, so MFBC, so MFBC will be, so MF, sorry, M, not MF, it will be MBC will be equal to MFBC. What is the value of MFBC? We have already calculated MFBC, this one. MFBC is minus 40.5 plus 2E, I is 1.5 I upon L is 4 meter, brackets 2 theta B plus theta C. Okay, and delta will be considered as 0. Why 0 here? Minus 3 into 0 upon L. Why 0? Because we are considering theta BC. This equation is for end B. Okay, when I am saying MBC means I am writing for end B. Okay, so when MBC I am writing, then this delta will be, it will consider the settlement of support B, not of support C. When I will write MCB, then I will consider this delta. Okay, MCB or MCD, in both the cases I will consider delta, but for MBC and MDC I will not consider any settlement, because these supports are not settling. Which one is settling? This C is settling. Okay, so MBC will be minus 40.5 plus 1.5 EI theta B plus 0.75 EI theta C. This is our question number 3. This is our equation number 3. Similarly, MCB will be equals to MFCB plus 2EI upon L 2 theta C plus theta B minus 3 delta upon L. So MFCB is 40.5 plus 2EI is 1.5 I, L is 4, 2 theta C plus theta B minus